Hello everybody, today we're going to have a look at some more trig modeling with some examples. Okay, so in fact just one example, right? Okay, these questions can be quite lengthy. They're usually in the section B of the standard level exam papers. So let's see if we can do one. Right, the height of the tide above mean sea level on January the 24th at Cape Town is modelled by h of t is equal to 3 sine pi t over 6. Where t is the number of hours after midnight. So we're going to first of all graph it in part A for t being between 0 and 24. Okay, so we need to take some information out of this so we can draw our graph. First of all, we know the amplitude, and that is going to be 3. It's the number at the front of the sine. We also know that we haven't got a shift up or down. Okay, we're going to be oscillating around a principal axis, which is the x-axis, or y equals 0. Okay, so that's useful to know. We better think about the period of the graph, how long it takes to complete a rotation. So we get the number that we are kind of multiplying the t by in this case, which is pi over 6, and we do 2 pi divided by that number, and that's going to help us find the period. So that will be the same thing as 2 pi multiplied by 6 over pi. The pi's are going to cancel. We can see that the period is 12. Okay, so from there, I think we've got enough information to be able to plot this. So let's draw some axes. So we're going to have an axis going from 0 to 24. Put some other values in there to help us as well. Okay, and we know we're going to have 2 complete rotations or 2 complete waves through our time limit. If the period is 12, we know our max is going to be positive 3 with an amplitude of 3. We have a minimum of -3. So I think we're in good shape here. Okay, so it's a sine wave. We're starting from 0, and we're going to finish this again in a period of 12. So we're going to be at 0 on those points. Of course, it's a sine wave, so in the middle of that, we're also going to be at 0. We're going to be up, followed by down, followed by up, followed by down. This is going to help me to draw the sketch I'm looking for. So our diagram, our very rough sketch illustrating the key points, is going to look something like this. Okay, right, so part B, when is high tide and what is the maximum height? Well, clearly the max height is 3, right? So max height, 3 meters. Okay, when does that occur? Well, it happens at 3 a.m. It happens also at 3 p.m. Okay, at 15. T is 15 and 3 p.m. So that is going to be our answer for part B. Right, C, what is the height of the tide at 2 p.m.? Okay, so if h is our function, what we've got to find here really is h of 2. So h of 2 is going to be 3 sine of pi over 6 multiplied by 2. Right, we're swapping in the t for 2. What will this be? Well, we can use a calculator. These questions are calculator based, so we can type some numbers in, press a button, and we should be able to work out that we have 2.60 meters above sea level as our height. Okay, D. A ship can cross the harbour provided the tide is at least 2 meters above sea level. When is crossing possible on January the 24th? Okay, for this question, we're going to need to consider another graph, right? So we're thinking about 2 meters above sea level. So if we imagine the 2 meter line here, right, you can kind of clearly see that it's possible between certain specific values of x, right? Okay, so if we can find these points here, then that will be our boundary where the height is above 2 and the ship can cross. The good news is we only have to do this a couple of times, not 4 times, because the period of our graph is 12. So we can just add 12 to our answers for the first sort of raise above 2 meters, and that's going to be the second peak as well. Right, okay, so let's do this. Now, the method really is to plot this on a calculator and find some intersection points, right? So we'll start off by on the using the y equals button, plotting the function of y1 is equal to 3 sine of pi t over 6. Set your boundary window carefully. Obviously, you need to have t is going to be between, or x, the x-axis, I should say, is between at least 0 and 12, but you might want to see the whole thing 0 to 24. Obviously, your y-axis between at least 3 and minus 3. The second thing we're going to plot is y is equal to 2. That will get the exact replication of what we have in the diagram here. We will use the intersection feature, and we should be able to generate some values. Now, if we find the intersection feature, we are going to end up with, let's call them T1 and T2, T3 and T4. So if we find those, we're going to have that T1 is 1.39, T2 is 4.61, and if we add 12 to both of those, we can find that T3 is 13.39, and T4 is 16.61. Now, that isn't quite good enough to give us our final answer because we need to have these times in hours and minutes. So we really, and in fact, on a 24-hour clock. So what we want to do is take the decimal version. So for example, in T1, 0.39 of an hour. And because there's 60 minutes in an hour, if we times each one of these by 0.6, we are going to have it in terms of the minutes we want, right? So the T1 by this process will end up looking like this, 1:23 a.m. So taking, again, in T2, taking the 0.61, multiplying by 0.6, we're going to get 0.37. So this corresponds to 4:37 a.m. So, okay, so there's our two values there. Again, we can add 12 to this, and in fact, let's just use AM and PM. So we're going to have 1:23 p.m. and we're going to have 4:37 p.m. Right, so those are our values. So to write this out, the ship can cross between 1:23 a.m. and 4:37 a.m. And also 1:23 p.m. and 4:37 p.m. Okay, that is the full question. You should have a look now at the questions in the book and see how you get on. Best of luck.